Hello, this video is about GEMS, which is a new UKRI-funded research project aimed at extracting heat from mine water. This novel green energy source will provide an efficient way to decarbonise the huge heating demand in the UK. GEMS stands for Geothermal Energy from Mines and Solar-Geothermal Heat, and it is a project run between Durham University, the British Geological Survey, and 7 key national and international project partners. There are about 23,000 mines in the UK, almost all disused and flooded today. 1 in 4 homes are built on top of or very close to one of those mines. The typical water temperature is between 12 and 20 degrees, which is not really hot enough to directly use it, but using heat pump technology, this heat can be used to provide much warmer water of 40 to 50 degrees. Mine water can probably warm those homes for at least the next 100 years. And the way this works is illustrated in this schematic diagram. A circulation is set up in which warm mine water is pumped up through a borehole or an abandoned shaft. Heat is then extracted using a heat pump and transferred into clean water that is then distributed to the end user. The cooled mine water is injected back into the mine system where it warms again. But in order to make mine water geothermal heating an efficient heat source, we still need to address a number of challenges. First, we need to ensure that heat extraction from the mines is efficient and economically viable. Mine water can be environmentally polluting, so we re-inject this water back into the mines after heat extraction. But this sets up a circulation that we need to understand well. We don't want to pump up cold water that has just been injected. So to investigate this, we developed a novel numerical modeling tool to calculate where and how much water can be extracted without depleting the underground heat source. These models, they rely on accurate mining information and knowledge of heat exchange process. So we will work with mine plans from the Coal Authority and with the Glasgow Geo Observatory to test heat exchange scenarios to calibrate these numerical models. We also need to handle significant fluctuations in heat demand. In winter, we need a lot more heat than in the summer. Gas boilers can be easily switched on and off, but for mine water geothermal, a better solution is to store the heat. And in GEMS, we're looking at various scenarios, including novel heat storage devices or using the mines as heat stores. So in winter, we extract warm water from the mines, and in summer, we use solar energy to return warm water back to the mines. And what are the practical implications for the end user? Gas boilers are to be phased out within the next decade or so, and heat networks might replace them. And the 40 to 50 degrees water from these mine systems is probably more suitable for underfloor heating. So some retrofitting is probably needed, and we need to work together with the end users to minimize disruption. Finally, mine water geothermal heat is a fairly new technique in the UK, and we want to make sure that government regulations and investment schemes are suitable. We also want to make sure that everyone benefits from this new green energy source, including, for example, the mining communities that built the mines in the first place. GEMS aims to deliver solutions to all these challenges. I'm Jeroen van Hunen, and if you want to know more about this project, please feel free to contact me.